Welcome to Across the Globe. Today we will learn about basic control structures. Control structures are crucial in programming to manage the flow of code execution. They come in three fundamental types: sequential, selection, and iteration. 1. Sequential control structure executes code line by line in a top-down order. For instance, in a payroll program, calculations for each employee can happen sequentially. 2. Selection control structure includes decision-making processes like if-else statements. It enables the program to choose between different paths based on certain conditions. For example, in a shopping cart application, if the user has a certain product in their cart, a discount is applied. Iteration control structure allows for repeating a block of code multiple times until a specified condition is met. For instance, in a loop that calculates grades for students, the process repeats until all students' grades are evaluated. Understanding and utilizing these control structures effectively provide developers with the tools to craft robust and dynamic programs. The sequential control structure in programming dictates that statements are executed in the exact order they are written, from the top to the bottom. In the provided example, first, the variable name is assigned the value Alice, followed by the variable age being assigned the value 25. Subsequently, the program prints out the name and age using the print function. This program would output name Alice, age 25. This clear, linear flow of execution characterizes the sequential control structure and is fundamental in determining the order of operations in a program. The selection control structure is a programming feature that enables the execution of distinct code blocks based on specified conditions. In the example provided, a variable num is set to 10, followed by an if statement that checks if num is greater than 0. If the condition is true, the program outputs number is positive. Otherwise, it prints number is negative. This type of structure allows programs to make decisions dynamically by evaluating conditions and selecting the appropriate code path accordingly. The iteration control structure in programming enables the repetition of a specific set of statements. For instance, in Python, using a for loop with range function can iterate a block of code a defined number of times. In the provided example, the loop iterates 5 times, printing iteration followed by the current value of I each time. This mechanism proves beneficial in scenarios like processing a fixed list of items or executing a task a certain number of times. Basic control structures are fundamental elements for organizing and optimizing code. They include conditional statements, loops, and control flow mechanisms. Conditional statements like if-else allow you to execute code based on specified conditions. For example, you can use an if statement to check if a variable is equal to a certain value before executing a block of code. Loops, such as for and while loops, enable you to repeat code multiple times. For instance, a for loop can iterate over a collection of elements to perform a set of operations on each element. Control flow mechanisms, like switch statements, provide an efficient way to implement multiple branching options based on a single expression. They are particularly useful when you have several conditions to check. By mastering these basic control structures, you can enhance the efficiency and flexibility of your code, enabling you to create more dynamic and adaptable programs. Just as following a recipe requires following steps in a specific order to create a dish, a computer program uses basic control structures to execute commands in a logical sequence. Similar to a traffic light controlling the flow of vehicles on the road, conditional statements in a program determine the flow of instructions based on certain conditions being met. Like a loop on a roller coaster track, continuously taking riders for a ride until a certain number of loops have been completed, loops in a program repeat a set of instructions until a specific condition is met. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code showcases a scenario where we are simulating preparing a dish based on a recipe using basic control structures in R. The first step involves gathering a list of ingredients necessary for the dish. These ingredients are later mixed in a function mix ingredients, employing a for loop to iterate through each ingredient and add them to a mixing bowl. The mixing process is visualized through the print statements. Next, the code checks the oven's temperature using an if statement. If the oven temperature is greater than or equal to 350 degrees, the oven is preheated to the desired temperature. Otherwise, the program waits for the oven to reach the specified temperature before proceeding. The final steps involve baking the mixture in the oven for a specified duration and announcing the readiness of the delicious dish to be served. The entire process is meticulously controlled through the logical flow defined by if and for statements. Output from the code execution provides a glimpse into the overall progress of the dish preparation, mimicking the real-world scenario of cooking a dish by following a recipe step by step. One industrial application where basic control structures are crucial is in manufacturing processes. For instance, in an assembly line of a car manufacturing plant, control structures are used to manage the flow of components, check for quality control at various stages, and ensure that the assembly process follows a predefined sequence to build the car efficiently and accurately. Another real-world application of basic control structures can be found in automated temperature control systems in greenhouses. By using control structures like loops and conditional statements, the system can monitor and adjust the temperature inside the greenhouse to create an optimal environment for plant growth. This ensures that the plants receive the right amount of heat and maintain the required temperature levels for their development. In both these cases, basic control structures play a fundamental role in guiding the operations and decisions within these industrial settings to achieve specific goals effectively and maintain quality standards in their processes. Across the globe, industries leverage basic control structures to enhance efficiency, accuracy, and consistency in their operations, demonstrating the universal importance and applicability of these programming concepts in diverse real-world scenarios. Keep learning, stay curious, and I'll catch you in the next video.